webinar during the Productivity Week celebrations. And you all know that the theme for the National Productivity Council for the year 2026 is unlocking the theme for the country from the National Productivity Council is clusters as growth engine, maximizing productivity in MSMEs. And we had a productivity conclave as part of the week's long celebration on the 12th of this month. And we have a theme for that conclave as unlocking as MSMEs potential for sustainable growth. And as a part of the celebration today, we have this webinar, and the webinar as a theme or a title, which is very closely linked to the National Productivity Council's theme. So the topic today is cluster-based Industry 4.0 adoption for enhanced productivity and energy efficiency improvement in pump manufacturing MSMEs. And our speaker today is Dr. Millerjothi, and I have the privilege of introducing him. So he is working as a professor, head of Advanced Research Center for Green Technologies and Sustainabilities in Ishwar College of Engineering in Coimbatore. He has his bachelor's degree in mechanical engineering from Guindy College of Engineering, Guindy, and he has got a master's from the same college on energy engineering. And he is having a PhD in alternative fluids from the same college, belongs to Anna University. And his areas of specializations are thermofluid engineering, energy conservation audit, energy management, renewable energy systems, internal combustion engines, alternative fuels, and thermal power engineering. With that brief introduction, let me once again remind you the topic for today is closely connected to the National Productivity Council's theme. The topic today is cluster-based Industry 4.0 adoption for enhanced productivity and energy efficiency improvement in pump manufacturing MSMEs. With that note, I pass it on to our speaker today, Dr. Millerjothi. Welcome you, sir. Thank you for joining us. The stage is yours.
Thank you, sir. Thank you very much, Mani Narayanan, sir. Thank you very much. So, I would like to thank Mr. Ravi Kumar, Honorable Secretary, Mr. K. Jaganathan, Chairman, PwC, Dr. S. Sudhakar, President.
Volume feeble, sir.
Hello, are you hearing, sir?
Now it is hearing.
Now it is hearing. Okay. So, Dr. Sudhakar, President, CPC current President, and Engineer K. Arul sir, ex-President CPC. Last but not least, Bhavani Madam Manager. So thank you for the all organizers. So I would like to thank everyone to given the opportunity to share my ideas and knowledge to the participants. Let me share my presentation. Are you able to see?
Yes, sir, it's visible.
Very much. Okay, sir. Today the session is cluster-based Industry 4 adoption for enhanced productivity. It's the first phase. The second phase will be completely technical. That is how to conserve energy in the pump manufacturing MSME. That is completely technical. So the highlights of the presentation is, so what is the role of MSME cluster? Introduce Industry 4 for pump MSME. What are the current challenges in pump MSMEs? What are the energy conservation opportunities in pumps? This is technical session. And some of the information on subsidy for promotion of energy audit conservation under the scheme. The pump manufacturing MSMEs are the backbone of India's for water, agriculture, irrigation, and the industrial ecosystem. However, rising energy costs, quality expectations, and the global competition across the country is a more demand in a new approach. So today's discussion focus on how cluster-based industry 4 adoption can be enhanced productivity and energy efficiency without burdening of individual MSME and the energy conservation itself. So what are the typical pump MSME cluster ecosystem? It consists of 5 organizations: foundries, machine shops, motor manufacturers, assembly and testing units, suppliers and service providers. The 5 units are considered as clusters. A pump cluster is not a simple ecosystem. It is a many MSP grow together. What are the current challenges in pump MSMEs? Most of the MSMEs operate with conventional technology and manual monitoring and limited data. Also, productivity losses are there with respect to energy wastage or often hidden because of measurements itself is missing. So what is the solution? The solution is Industry 4. So the Industry 4 helps see the analysis, optimize these losses. What are the current challenges in pump in MSMEs? Frequent stoppages and inefficient workflow. This leads to low productivity. Energy losses and the inefficient equipment consume more energy consumption. Quality inconsistency, manual process. So these are the current challenges in production of manufacturing pump in MSMEs. So how do you overcome? These productivity losses in pump MSMEs arises from quality issues, lot of downtime, and skilled expectations are very limited. Most of the productive losses in pump MSMEs are not due to lack of effort, but due to lack of data, planning, and skilled work. What are the energy efficiency challenges in MSME during production of pumps? So energy losses in pump MSMEs occur due to inefficient equipment and lack of energy discipline. You cannot improve energy efficiency if energy is not measured. No measurement, definitely energy losses will be there, which leads to higher cost. So what are the current energy efficiency challenges in manufacturing in pump and MSME? High energy consumption and equipment losses by using of inefficient methods. It cannot be tolerated with a poor power quality supply. It leads to voltage fluctuation and harmonies. No energy monitoring system in MSMEs. It is hidden energy wastage and the data is also missing. So the entire solution is go for Industry 4. So Industry 1 started in 1840 in England. It is a completely mechanism can be done by the steam and the water power production. Industry 2 started until 1914 during the World War, First World War. So all the mass production and the machine operations can be done by the electric power. Then Industry 3 revolution started until 2000. It can be done by the electronics and the computer, integration with the electronics and the computers, fully automation. At present, the 4th major challenges in industry development is Industry 4. Smart and connected all machines, digitalization plus human. These are the key concepts of Industry 4. IIoT, cyber physical system, all real-time monitoring, decision making can be done by the using of data analytics, using programmable machines robotics to carry out physical tasks automatically by automation robotics. All the data can be stored in the cloud by the concept of cloud and the edge computing. Finally, the revelation is way artificial intelligence and predictive. If it does, right, all the data can be analyzed, predicted, fixed before it fails. Now, the question is, why Industry 4 for MSMEs? We have seen the previous slide what are the challenges and the current scenario in MSMEs. But the Industry 4 helps MSME produce more product, less weight, and compete, of course, across the nation and across the globe. Industry 4 is not about expensive robots. It's a smart one by using of data. Industry 4, mainly it is called fourth industrial revolution. It's the concept of using digital technologies to make industry smarter, more efficient, and connected. The difference of traditional MSME and Industry 4 MSME is reactive is the traditional, predictive is Industry 4. Manual tracking is traditional, digitalization and the dashboard visibility is Industry 4. High rework in traditional. Do it the first time and attack the first time is Industry 4. In traditional MSME, all energy is in blind in nature. But in Industry 4, energy is completely open, aware. So what are the applications in Industry 4? It uses of digital technologies to make manufacturing smarter, faster, and more efficient. Industry 4 technologies for pumping MSMEs are practical digital tools that monitor emissions, energy use, and production to improve efficiency and performance. One thing I wanted to tell, Industry 4 is not about replacing people. It is about supporting human decision using data, sensor, and digital tools. Industry 4 is not full automation in the overnight in MSME. It is a step-by-step journey, not a sudden transformation. Industry 4, not a high cost for MSME. It can be affordable, scalable solution, or available for MSMEs. It is not a replacement of manpower. It is support people, those who work with the MSME. It improves the skills and reduces manual errors. So again, I am insisting Industry 4 is not replacing people. It's a smart one. What are the productivity improvements while using Industry 4? Reduced downtime, improved machine utilization, better production planning, and reduced labor. These are the main. So each and every topic, due to the time restriction, we cannot discuss earlier. Only highlights only we are going to discuss. Now, what is clustered here? Already we have discussed while preparing of pump manufacturing MSME. It's not an individual MSME. It's a pie organization. Is considered as a cluster, right? We have discussed a foundry, right? Machine manufacturing process, motor manufacturing, and suppliers, etc. Right? These are the clusters. So why it is necessary? Cluster-based adoption makes Industry 4 affordable, faster, and more effective for MSMEs. Cluster converted high-cost technology into shared investment, scalable solution for MSME. One industry of MSME may hesitate to adopt Industry 4 due to the cost or skill limitations. For that only, the solution is cluster-based of manufacturing in India. The cluster-based manufacturing allows shared investment, shared learning, shared risk factor also. That's why cluster-based adaptive is ideal for MSME. So what is the energy efficient improvement using Industry 4? Continuous tracking of power consumption. That means the real-time energy monitoring can be done by using sensors. Identification of energy loss. It's a direct wastage, ideal running time, and inefficiency that can be monitored. By using Industry 4, demand side management also can be identified and solved. So implementation of challenges for Industry 4 in MSME. These are the challenges. Why it is not being implemented in MSME? Thing is, initial investment concepts. Each and every MSME people are fearing about the high cost because of the high investment and uncertain payback. And still limited expertise by using of digital and energy tools and AI tools also. Right? But most of the MSPs are practicing the traditional practices in manufacturing firms. Still they are not changed into AI technologies. And also, right, when they can go for higher technology, they are concerned about the data access and the systems. So these are the clusters overcome these challenges. Clusters reduce the risk caused by sharing investment, skills and support systems. Clusters convert individual challenges into collective solutions. These challenges are common, but cluster-based adoption helps reduce risk and build confidence. This is the only solution to overcome all these challenges. So what is the support obtained from the government and the institution? So government support through the MSME funding, training and the technology assistance. So the technology assistance with respect to the institute can be obtained in IIT Chennai Madras. Many NITs who have support collaboration with MSME to implement latest technology, say for artificial intelligence. So effective collaboration between government, industry and academic accelerates the Industry 4 adoption. So second phase, now we are going to discuss about what is the energy efficiency measures in pumping system. So how do you find out the possibilities of energy measures in the pumping systems? That we are going to discuss, completely technical. I hope all the engineers can be able to follow. Even non-technical people also can be able to follow in this seminar. In the pump account, statistical analysis says the pump accounting for 15% share from the national electricity consumption. 40% of the electricity used from the pump in all over industrial sector. 100% of the electricity consumption in agriculture. This is the statistical analysis. What is the scope in pumping system? What would be the savings? What is the benchmark? Minimum 30% of the savings can be directly obtained from the pump. In appropriate measurements can be implemented. How? In generally, the pump initial cost is around 3.2% only. During the operation, the maintenance cost is 1.3%. But the energy cost during lifetime period, the energy cost will be 95.5%. I'll give a small example. A small pump, a capacity of 7.5 kilowatt, the energy cost would be 15 lakhs in about 10 years. If you go for higher The 37 kilowatt of pump, if it is working 10 years, it is around I think it is 37 lakhs. Okay. Now this is the main important technical data in the pumping system. The left hand side is well designed pumping. The right hand side is actual pumping system. The well designed, the motor efficiency is 90%. Then we can give 100% energy to the motor, right? Of course, 10% losses will be there. So 90% goes as a pump input. When the pump considered as a 85% efficiency, definitely 13.5% pump losses will be there. So the pump output will be 76.5% pump output. This 76.5 pump output, when it is implemented accounting into the valve losses about 15.3% and 12.2% in the piping system where leakages and flanges. Finally, the useful energy would be 49%. So the well design itself, 100% energy will be reduced into 49%. Coming to the MSME traditional pump manufacturing system. When I am giving 100% energy into the motor efficiency is 85% in the conventional motor. So when it is accounted to 15% losses, the 85% output comes out from the motor. This is input to the pump. When considered as 70% of the efficiency and 25% pump losses will be there, then finally it is reduced to 59.5% output as a pump output. Considering valve losses about 30% and the leakages losses about 15%, so finally, right, the conventional motor 100% energy is reduced to 15% only. So we need to be very careful, right, how to save the energy in the conventional pumping system. So before that, we need to understand what would be the basics of the pump. Very important to analyze the basics, study the basics. 5 important parameters. Volume of liquid delivered, that is called the discharge, liters per second. So what would be the liquid this pump, that is head, liter of water column, and shaft power, that means the power obtained to the shaft power in the pump, in terms of flow. Efficiency of a pump, the power imparted on the fluid to the power given to the pump shaft. This is the ratio, so called the efficiency. Of course, specific speed. Now we need to understand what is the basic law of pump. Without analyzing of basic law and the concepts, we cannot go for measuring the energy conservation. That's why I'm going to give you a brief introduction about the basics law. The discharge, that means the volume of fluid discharged from the pump is inversely proportional to the head. That means when the discharge increases, obviously the head will be decreases due to the pressure. And discharge, that means volume of fluid delivered is directly proportional to the power. Similarly, the discharge is directly proportional to the efficiency. You can see the graphical representation. X-axis discharge, and the head is, when the discharge increases, the head is gradually decreases. When the discharge increases, power is increases gradually. Similarly, efficiency also increases. Right. What would be the safe side to optimize the pumping operation? Please understand in this graph, the blue color, the blue color, that is called a characteristic curve. It is the performance of the pump. This dark line from upward direction, this is called system curve. The system curve belongs to pipe system, wall arrangements, fitting arrangements, elevations arrangement. That is called the system curve. Right? So the characteristic curve and the system curve, where it is intersects, that is the operating point. So this point is called as energy efficient point. When the system curve shift in right hand side, or when this system curve shift in the left hand side, more impact will be there. That we are what would be the impact that we are going to discuss in the coming slide. So please understand the blue curve is a characteristic curve, and the thick dark line is upward direction is a system curve. This is pump generous graph. Okay, now we are going to discuss what would be the possibilities of energy savings in pumps. First, we need to understand what are the reasons for excess power consumption, energy leakage. Many industries are selecting a wrong selection of pump. They are not selecting exact capacity of pump. Just like that, they borrow and finally they are confused why energy consumption is low because of the wrong selection of pump. Over design, over capacity, improper layout of the pump, and many industries we have used 20 to 30 years of pumps still they are using as a old linear efficient pumps. Multiple smaller size pumps many industries are using. These are the main reason for excess power consumption. So how to sort out? What would be the rectifications? First, select the correct size of the pump. We have to identify how much head is required, how much distance, height I want to pump the liquid. What would be the flow is required for the process? What is the specifics? So this will be useful to determine the power and the efficiency. Right. Coming to the head and the discharge selection. So two impellers are displayed. One is a wider impeller, other one is narrow impeller. When the wider impeller, the width is more. So when the width is more, the impeller, the flow passage area is higher. So the water can passes easily. So larger flow area reduces the velocity loss. So when the reduces the velocity, obviously lower frictions and lower hydraulic losses. So you can see the graph. The friction also will less. Not it is almost stable. Then we can go for narrow impeller. You can see this, the width area is very narrow, so that it can be reduced to flow passage area can be seen. So when the passage is restricted, the flow obviously restricted. So that's why the more restriction, okay, more frictions also there. So the head the curve is steeply falling. So simply I can say wider impeller have higher discharge and less friction. Narrow impeller have lower discharge and a rapid head drop. Coming to the vans. So what selections we can go for? Higher vans or fewer vans? When we can see the head and the discharge curve in the more vans, more energy transfer from the impeller to the fluid is very smoother. So the flow is increases with respect to more vans. In the more vans, the head also decreases slowly because of the discharge increases. The vans reduces heat losses in the more vans. You can see the graph. There is no drastically reduce. The graph is stable condition. When we coming to the lesser bands, the flow guidance is very poor, and the slip and the turbulence also increases due to the lesser band guides. You see the graph, head drops quickly as discharges increases. So lesser bands overcome more recirculation and energy losses. So depends upon the requirements, the manufacturers can go for more bands or fewer bands. Coming to the energy efficiency motor, the pump need always connect the shaft with respect to the motor. Many MSME, all motors can be manufactured by the standard motors. But with respect to the energy conservation point of view, the pump should be connected with the energy efficient motor, at least EI1. IE1, IE2, IE3, IE4. So many ratings are there. At least energy efficiency motor rating 1 should be mounted. In order to calculate the power, we can use this formula. Now, what are the three types of efficiencies in the pumping system? Hydraulic efficiency, volumetric efficiency, mechanical efficiency is to be considered as a pump efficiency. When we can add motor efficiency, we can calculate overall efficiency of the pump. What are the losses? How do you estimate the losses? How to save energy by minimizing the losses? First one is hydraulic losses. The hydraulic losses, there is a diffusion losses are there. The diffusion losses, where the diffusion in the diffuser, the fluid is converted, the kinetic energy of the fluid is converted to the pressure energy. And the losses in the casing, losses in the impeller, losses in the friction. It is amounting to 15 to 20%. Volumetric losses will be there. Due to the leakage losses, the volumetric losses is highly limited. It is accounted to 3 to 5%. Of course, mechanical losses will be there. It leads to bearing losses and other transmission losses. When we can represent in the pie chart, mechanical losses is 2 to 5%, hydraulic losses 15 to 20%, and volumetric efficiency is 3 to 5%. So the overall pumping efficiency is 70 to 80% only. How to minimize the friction losses? Avoid using bends and the number of fittings. Friction loss is directly proportional to the velocity scale. The solution is how to minimize the friction loss. Identify the higher pipe size, it leads to lesser friction loss. You can see this graphical representation. I am selecting 100 mm diameter pipe, 80 mm diameter pipe, and 60 mm diameter pipe with respect to the head loss. When we can go for 100 mm diameter, the friction loss is very minimal. Gradually, when the diameter is decreases, say 80%, sorry, 80 mm diameter and 60 mm diameter, right? The weight losses is slowly increases, right? So higher size of pipe normally reduces the friction loss, and the minimum lesser size of the pipes increase the friction loss. So I can give the case study. Okay. So good lesson is always select the pipe in the next highest size. While selecting the pipe, be liberal, be generous. So this will be the case study for the friction losses. For example, a pipe life is 25 years. When I am considering amortization is 4%, interest is 10%, maintenance is 2%. The pipe operation cost is amounted to 60%. Right. Now coming to this table column, so I am taking 80%, 80 diameter pipe size, 100 mm diameter pipe and 150 mm diameter. That pipe cost is given in the 60,000, 95,000 and 1 lakh 30,000. The operating cost is 60% as we calculated in the previous slide. This cost is around this much. When we are considered a friction cost, 80% diameter pipe friction cost is around 47 and the 100 mm diameter pipe friction cost is 16 and 6. So it is directly related to the power cost. The friction cost is directly related to power cost. So the power cost will be this much. When the power cost, that means the unit consumption is, I convert it into rupees. Assume that the unit cost is rupees 8 per unit. So the column 4, so the operation cost and the power cost, when I'm adding put together, the total cost is 5.1 lakhs for 80 mm diameter. For 100 mm diameter, the operation cost is 1.9 lakh. For 150 mm diameter, the operation cost is 0.8. So when the pipe size is increases, the friction cost also decreases. The operation cost also decreases. So that I am representing the percentage of cost. So 80% minimum diameter, the operation cost is 65%. Whereas the higher size of diameter, 150 mm diameter, the operation cost is very less, 12%. So the conclusion is go for proper higher size. So what would be the option for flow control? So there is a control in the valve method, throttling method, on-off mode type, and variable frequency type. These are the methods being implemented for the controlling of flow. You can see in the valve throttling process, already we have discussed. So this one is a performance curve. The thick line and the dotted line is a pumping system curve. The left hand side, sorry, right hand side, when the valve is in fully open condition, the flow is increases and the head is decreases. This scenario is for fully open condition. When I am reducing, that means closed in off condition, right? The flow is decreases. That means it is shifted to left hand side. The pump produces this higher height. It was lesser. Now from this diagram, from this image, we are seeing lesser flow rate, which leads to higher head. Is it a good case? It's a good scenario? No. When pump delivering a lesser discharge and a higher head, it leads to inefficient and the pump is unsafe. So always the pump should be operated in the optimal point. So this I want to show as a case study. While selecting the pump should be right capacity. For example, the capacity of the pump is 85 liters per second, but the process is prepared only 55 liters per second. So, in order to get 55 liters per second, I am closing for 50% is open. When I am calculating, the power will be 37%. Now I am going to open, fully open. That means when I am selecting the exact correct capacity of pump, where the process is prepared 55 liters per second. Right? So the valve is fully open now. So I am delivering 55 liters per second to the process. The power consumption would be 23. So what would be the savings? The valve throttling, that means the 60%, 40% closed, the energy consumption is 37 kilowatt. When I am selecting the correct size of the pump, that means 100% open, the savings would be 14 kilowatt when it is constructed. So directly we are getting savings when we are selecting the appropriate pump set selections. So many industries are selected higher capacity of pump. So what shall we do? So what is the option to correct to get the higher size of pump? Impeller trimming. The first option is impeller trimming. So the diameter of the impeller can be trimmed about a maximum 15%, 10 to 15% diameter. So this can be reduced the speed reduction by adoption of VFD. So before see the speed reduction, we need to understand what would be the relations of loss with respect to speed. Discharge is proportional to the speed, head is proportional to the speed sphere, power is proportional to the cubic speed. With respect to impeller, discharge is proportional to diameter sphere, head is proportional to the cubic diameter, power is proportional to the diameter to the power of 4. Now you can see the impeller trimming concept. This one is, I told you, this is a pump character system. This one is a system curve. Initially, before trimming, this is the pump character system where this point is originally served as the operation point. When I am trimming about a 10 to 15% after trimming, this system curve will be shifted to this point after trimming. So the operating point is reduced to this point. Right. Now we can see the difference. Discharge wise it is reduced and then head wise it is reduced. So this is the case. So when we can calculate the power, directly 15% can be saved. So this is a concept of impeller trimming. See here, diameter is 100%, flow is 100%, head always everything is 100%. When I am reducing to 10% of trimming, diameter of the impeller, the flow is 81%, head is 73%, power is 66%. So it is easily understand that from this slide, the 10% of trimming can result in 34% direct save. So should not trim beyond the 15%, otherwise it will be overtrimmed. So speed reduction. Similarly, the speed is directly proportional to power. When I am decrease the speed, that means the impeller speed 90%, the flow is reduced to 90%, head also reduced to 81%, power is 70%. Still further I am reduced to 80% speed, flow is 80%, head is 64%, 51%, power is reduced to 54%. So you can see from this tabular column, 10% reduction results almost 27% savings. We will reduce the speed. So coming to the this slide presentations, do not interchange the pumps unilaterally. This is very important. If any motor got failure, we can interchange. But any motor, any pump got failure, do not interchange. Because do not go the pump in repeated basis. Because the pump characteristic curve can be different. Of course, if any motors can found error or failure, we can interchange because same HP rating, same speed, same voltage of motor can be interchanged because motor performance is as characteristic standardized, whereas pumps are not. If each and every pump characteristic curves are different, efficiency curves are different, net positive and section head recurrence are different. That's why any pump is got failure, do not replace with another 10 execute them. This is the one. Coming to the leakage. Leakage leads to not only water losses, but also electricity losses. Everyone thinks only water is leaking with some measurable one, but everyone is ignored what will be the electricity loss. Right? So what is the solution? For example, this is a case study. The water is pumped from 18 kilometer distance. The total quantity of water pumped is around 4.9 million liters per day. The leakage quantity is estimated around 2.1 million liters per day. So the leakage percentage is estimated as 42.5%. So what is the how much lost? The water lost is estimated as 769 milliliters per year only. So what would be the energy lost? You see here, as I pointed out before, not only the water leakage quantification, we need to consider the loss of electricity also. Here, the energy loss is around 1.2 lakhs kilowatt hour per year. So this is very important. Of course, any inefficient pumps in the plant, you need to replace immediately, no sentiments. Right. So finally, I'm coming to the small information about subsidy for promotion of energy audit and the conservation of energy under the PCC. So the Tamil Nadu government provides a reimbursement for energy audit consultancy to MSME through promotion of energy audit and conservation of energy. There is a GO number 36 announcement made for special scheme to promote energy efficiency in MSME. So what are the objectives of this scheme? Promote energy efficiency awareness, encourage certified energy audits, support MSME financially, reduce energy intensity and carbon footprint, improve productivity through energy savings. So what are the reimbursements? The subsidy details. 75% of the cost of the energy audit fee can be reimbursed. That means maximum subject to the ceiling of 1 lakh per unit. What are the additional incentives? In case if you have done energy audit the particular industry, the energy auditor given proposals. So based on the implementation of energy auditor proposal, for example, at least 10 to 15%, you can save the energy by the showing of evidence. You can get 50% of the cost by the replacement of machinery and the equipment. Maximum 10 lakhs rupees you will get for this subsidy. This is a very interesting scheme. So how to apply? So the documents, I'm going to the next slide. What are the documents to be uploaded that I'm going to see here? There is a list of documents: registration certificate, conducted load group, auditor accreditation certificate, official letter of engagement or acceptance from the energy auditors, auditor employment proof, energy audit agreement, detailed energy audit report, expenditure statement, and the pay proof. All those things you need to upload the MSP single window portal online, given by the district industry centers. Each and every district you have district industry centers. There you have to go and approach what would be the budget is available in the current financial year. This is for your information. Up to 24-25, right? Nearly about 15 lakhs have been dispersed in the 23 units as a subsidy for promotion of energy audit under the P scheme in Tanjavur district. This is for the information. So the CPC has done energy audit in the GK Dairy Industries, Kumbhakonam, Tanjavur districts. So the CPC have done energy audit under the P scheme. They got the subsidy and 15% they have minimum method. Now they are, I think they might have got that minimum 50 lakhs, 5 lakhs, what they have saved. That is, I came to know that. Okay. So based on that, the CPC has done energy audit. They gave the letter of appreciation that stated that the anti-tax savings 49 lakhs per year they got with the one-time investment of 43 lakhs with the payback period of November. The annual COT reduction they estimated around 3,000 lakhs. So I am stopping the my presentations. So I am looking forward for the questions from the participants. Hello, sir. Any questions? Hello? Hello?
Sir, yes, sir.
Yes, sir, please. Sir, any questions?
No, sir. If there is no question,
No participants? Any questions?
anyone can give feedback among the participants. Yeah. Anyone? Can you give any feedback? Okay, sir. I think
So maybe
I'm
it
outside.
will be technical. So I hope everyone should understand the technical point of view. Okay, thank you for given opportunity to share my thoughts and ideas. Okay, thank you, sir.
Thank you, sir, coming to the CPC for Productivity Week and giving a valuable inputs for us. This is a golden opportunity for us to have your participation with CPC.
Thank you, sir. Thank you. Thank you.